let's answer the second question, and that's the question: are there differences between males and female scores, even taking into account different majors? So this is the question whether or not there's a main effect due to gender. So the null hypothesis, there's no main effect due to gender on scores, and the alternative, there is a main effect. Well, this is the same thing as saying that beta 5, our coefficient, is 0 or not equal to 0. Or the model can be reduced by eliminating that predictor variable, or the predictor variable is needed. Okay, so let's go ahead and do our testing. And so we already have a full model. Let's do a individual model. So we're going to fit the regression, and the only thing that we're going to keep are the 4 majors. So we're eliminating the gender for this one, and we can hit OK and look at that. Or we could do the full one and do the full model where we have major, bio, psychology, and gender as well. And while we're here, you might as well do the 4-in-1 plot and the residuals versus each variable, and I'm including all gender, female, and majors all the way to psychology, and then hit OK. And we could take a quick look at our normality plot. Looks good. In this case, I don't think I'm going to need to go ahead. There's maybe narrowing, but you only have 2 choices, so it's really difficult to know. So the residual analysis looks okay. All right, now let's go ahead and calculate our t-statistic. So just as a reminder, because we're only eliminating one variable, we could either use the t-test, because we're only eliminating one, or the partial left test. Remember, the partial left test you could use for everything if you wanted to. But in this case, just to change things up, we'll use the t-test. So the t-test is the estimate minus the null minus standard deviation. And remember, if I did the full test, this has everything, bio, other, PE, psych, and gender. I can go ahead and look at the coefficients for gender. So the coefficient is 121.7, standard error is 49.2. All right, so let's go ahead and calculate that. 121.7 minus 0, 49.2, we get 2.47. Hey, that's the same number over here. I can go ahead and do the distribution plot with 21 degrees of freedom, just because that's what I had for the standard error there. And I can calculate that. I get 0.011 and 0.011. So let's go ahead and answer the question. With a p-value of 0.022, we are going to reject the null hypothesis. So there is a main effect due to gender, not Kylie, gender. Beta 5 is not 0, and the predictor variable x5 is needed. So any of those three in stat speak is okay. So at a significance level of 0.05, we would reject the null hypothesis. Just as a note there, make that change in your course pack because there is an error. I think your course pack says that there is not, we would not reject the null hypothesis, but the correct response is that we would reject the null hypothesis. See over here, I think this one says not. You need to get rid of that not and say, no, we would reject the null hypothesis. All right, so make sure you do that. And so we could then conclude that beta 5 is not 0, and the average for males and females differ even after adjusting for all possible differences in majors. So in other words, and for this particular data set, for this particular class, it kind of led to the idea that females were getting higher scores in this introductory statistics class that the author of most of the course pack materials provided. Okay. Your results may vary because, remember, the data could have been different, and so the data might be different. Plus, this is not intro to stats. Okay, I'll try to do some homework examples for the next video.